Hello and welcome to the E-Mobility Innovation Podcast, the podcast on e-mobility for research and industry. My name is Simon Voss, and in the coming episodes I'm delighted to provide insights on discussions I had with leading experts on the field of e-mobility at the E-Mobility Production Days hosted by PEM of RWTH Aachen. What's the status of innovation and where are we headed? Let's find out. Electric drives, what does it comprise of? Just to get a little starting here.
Okay, so the EV drive system is what is replacing the combustion engine. So if we think of it in the analogs of diesel, we are replicating what is the high pressure fuel injection system with our inverters that manages from the energy storage, which is the gas tank on the diesel or diesel petrol tank, and then we manage, instead of the battery, you have that. We take that energy, convert it over to electrical AC power, and inject it into the motor. The electric motor then converts that into mechanical power, just like the diesel engine block takes the chemical energy and converts it into thermal, then mechanical power.
What I would like to understand a little bit more what the customer challenges are currently and what the potential solutions are.
So we're focused within Cascadia Motion on serving the needs of niche and emerging volume customers. These customers, since they're smaller companies, don't have the internal expertise to develop their own battery electric vehicles, and they also have resource constraints. These resource constraints come from smaller revenue streams that support less involvement as far as research and development and less capitalization of new battery electric vehicles. So then what we're looking to do with Cascadia Motion is have a portfolio of off-the-shelf options that can be put into different segments that enable these customers to electrify their vehicles across the board with minimizing the investment. So we're bringing down the barriers to entry for these EV programs in niche markets.
So what are those niche markets that you would like to highlight?
On the top left here we see one version of a vocational. This is Battle Motors, formerly Crane Carrier. This is a street sweeper. A lot of low-speed driving, hydraulic drives that we convert over to electric. The same chassis and platform is also utilized in garbage collection. You think of a lot of start-stop. That use case is fantastic for electric vehicles. It is very difficult.
Because of your recuperation, right? Start-stop, you can...
Whereas in diesel cases, it's challenging because you're at the limits of the air system the full time. So emissions are high and fuel economy is low.
You have to get rid of the heat, to put it bluntly, right?
Yep. That's in another vocational market that's served very well by electric vehicles in commercial trucks are the terminal tractors. So we highlight that with the middle segment here.
So these are the tractors pulling the airplanes, correct?
This can be pulling airplanes, or this can also be logistics centers where they have hundreds of trailers that need to move from dock to dock as they load and unload. So in the marine, we see this in both areas. There's the legislation that on a lot of lakes and municipalities, they're wanting to go to electrification to minimize the pollution of the areas. So that's both of air pollution, but then also into the watershed. And then the other side of it is just the pleasure when you look at a ski boat or some of the other items that quickly need to get onto plane. This enables them to get onto plane quicker, create a more enjoyable ride.
You mean acceleration, right?
Exactly.
Performance.
And it enables a further broadening of the technology in the landscape. So you see on the right here, one of our customers, Navier, that is in the hydrofoil space. You couldn't do what they're doing today with an internal combustion engine.
Where are the constraints that you currently see, given that you have such new potential at hand now? But with that, of course, there are also boundaries that arise again, right? You push forward and then you see, okay, this is now the new barrier that needs to be overcome by means of innovation, and that's what we're also discussing here, right? And having this forum where we're trying to connect research with industry and together trying to pushing the boundaries. So what would you say from your industry perspective, what's the big lever that we have to pull yet?
I think the biggest thing is the education of the industry overall and the small customers that don't have the in-house expertise to develop the vehicles and the platforms themselves. They need some lessons learned around how they're going to launch their vehicles and how they integrate these systems into their platforms.
What's the biggest challenge there from the technical point of view?
The technical point of view, I would say, lies within the power modules.
Okay.
So there, it's about not only reducing energy losses during switching events, but then also minimizing any scrap throughout the entire manufacturing process. We're always going to be pushing for efficiency on the motor side. That's where we have probably the largest gap.
Where are we roughly, if you can state some
Yeah,
rough
so
numbers?
generation that's in production right now, 95% is kind of your peak efficiency in the heart
At
of
the
the
optimal
load
RPM,
speed.
right?
Exactly, the heart of the load speed map. And then this coming generation is going to be around 97% efficient.
Okay.
You compare that to silicon carbide inverters that are running 99-ish%, so there's still a gap.
Okay, let me ask you a question, because you're an expert on this, and I often heard this, but I want to have your perspective on that. You mentioned silicon carbide, right, as new inverter technologies. The switching times are getting smaller and smaller, right? And therewith the gradients of those switching peaks.
Yep.
Which, in my understanding, puts a greater stress on the isolation of the wiring of the motor. In terms of efficiency, I got your point, we can increase it, but what about longevity?
Yeah, so managing the DVDT that you're talking about is a key for balancing the thermals throughout the system.
So the voltage over times for everyone.
Yes, how quickly it ramps.
Exactly what we
and there you're spot on that we need to manage the insulation package and the wear out mechanisms there. But this is also, you don't want to over-modulate or go too quickly with your PWM rates, because you want to manage your thermal loading across the system. So what you can put in the motor versus what is in the power electronics, and there a slower DVDT will help manage not only longevity, but then you trade off a little bit on your efficiency from the inverter side.
Okay, gotcha.
You want the system to be in balance and across from the performance standpoint, but then also the cost structure, right? The technology exists to handle rapidly high DVDTs. However, you don't necessarily want to over-invest in the individual powertrain components such that the market doesn't utilize them, right? Because that strands then capital, or makes it prohibitively expensive for some markets to leverage the advantages of electric vehicles.
Yeah, can you give us a qualitative estimation of how the cost development in terms of in the range that you can also speak about it in terms of NDA, etc. The cost development over the technological innovation?
Right now, as we roll out inverters, we're typically at still the same cost standpoint when we go from IGBTs to silicon carbides over this next generation. So all of the design for value that's gone on is then being transitioned to getting the next bit of technology on the power module side in at the same unit cost for the inverter overall. So we get to manage that to the initial scale at no cost increase at the system level. And then the further generation is where you'll start seeing cost reductions as silicon carbide scales.
Okay, so you're aiming at keeping the costs as they are while increasing the performance, and then later on we'll see a cost decrease due to the maturing of the technology.
Exactly.
Great. I'm looking forward.
Thank you.
Joe, thank you very much for the conversation.
Thank you very much, Simon. Pleasure.